Hello everyone. Welcome to Codex Tech Rust Learning video blog. In today's video, we will cover our next exercise from Gophercises website. This will be built on top of the HTML link parser from the last video, although we will be using a very simplified, trimmed down version of that parser since we don't need as much complicated parsing, removing comments, etc. Before we jump into the code, let's look at one thing that we're going to cover in this video, and that is breadth first traversal or breadth first search. So this exercise is about building a sitemap. So user will provide a link to the base URL or a link to the site, and also they will provide how deep do we want to parse that website to build the sitemap. And we will use the breadth first traversal, which means we'll start with the parent that is level 0, and we will see how many links are there on that parent page. So that will be our level 1. So we will find all those links instead of just finding the node 1 or the first link and just go down that route. That will be depth first. So we will find all the links for the level 1 first, and then we'll go to the level 2, and on that one we do the same thing. We will find all the links for level 2 that are coming from node 1, 2, 3, and 4. So we will not just go level 2, pick up the node 1 child links, and then for each one of them, for instance, node 1.1 and node 1.2, we go down and find any child links. Instead, we will find all the links at the level 2 for node 1 or node 2, node 3, and node 4. And that's how we're gonna keep track of all the links that we are finding and keep building our sitemap. So that is briefly about the algorithm we're going to use. And now jumping into the code, let's start with the cargo.toml file just to see what are the packages that we're going to use in this exercise. So clap is the same package or the cargo um, dependency or crate that we are going to use. Clap we have used before in previous exercises. This is just to retrieve the command line input from the user and parse it. Next, we have quick XML. So this is one of the crates on crate.io that I found to be useful for generating XML file. It seems very intuitive, and we are using it because our sitemap need to be in an XML format that I will show next. It's certain format that we have to build. And then we have the scraper that is the same crate that we used in the previous HTML link parser exercise. So we will use it to retrieve anchor links from an HTML document or page. And next I'm using UREC. This one is just to make the request to different URLs, those anchor link URLs that we're gonna find um, from those HTML documents. There were multiple different crates that were available. It seems like request is another crate that is very popular, but I found UREC was simple and good enough for the work that we are doing, so I did not want to use any more complicated crate. The last one is the URL crate that is going to be useful for the work that we're going to do with the different URLs. For instance, when we find the links, we have to break down those anchor links href to find the base URL and then concatenate and then build any target URL that we want to further parse. So you will see soon in the code where we are using it. So these are the only crates or packages that we really need. Next, looking at the output. So this output is from free code camp. Um, so XML format is pretty standard. We have just the XML tag on top, and then this is our custom XML so URL set. So this is based on a sitemap specification. So URL set is there. Then we have URL. So for each anchor link that we find, we'll create this URL tag. So URL tag has a child tag of location, and that will be pointing to one of the URLs that we find on the page. Although there will be different types of URL present on the page, but we'll cover what URLs we're gonna extract when we look at the code, but we are not extracting all the different URLs, either the external, etc. But we'll briefly go over that next. So this is the file format, XML format that we have to generate, and that's why we are using that XML crate in our project. And this seems to be 375 lines. If I go and see this execution of this utility, you will see there were 124 links that were extracted. And by default, I'm only looking at the two levels, the parent and the child. And those links were generated and saved into this test.xml file. Let's, before we jump to the main.rs, let's look at the parser.rs because that is very simple. It's from the last exercise. We are using this struct first of all. So struct is just to build the href and text. We are not that interested in text. It's mostly the href that we are interested in, but I just kept the same implementation from the last exercise. And then we have this generate links. So we are passing an HTML doc, and it will parse that document and find all the anchor tags that are present on that one. And then we are just building this struct vector for that struct. So we find the href, and we get the href or link value, and then we also read the text and just get the text data from that one. So I'm using the simplified version of one of the text parsing that I showed in the previous exercise. So instead of doing any complicated parsing where we were trying to remove any extra spaces, etc. So I'm just saying collect all the text elements and then just add a space to separate them. So just the join part. So this is pretty simple. The main application is in the main.rs. So first of all, we are just including the parser, and then we have some use statements for the clap parser, XML, and file system since we have to write the file and URL. So those are pretty simple, nothing there. We are creating this use args for the parser, for the clap that we want to read these two inputs from the command line. One would be the URL. So user can enter or provide whatever URL they want to parse. And the next is the depth, that how deep they want to parse that website. By default, it will be 2. So if user does not provide anything, it will be 2. Because the more depth we want to, there will be more links generated. It will be more intrusive. So 2 seems to be very basic for what we need. Then we have this main method. Again, I'm using the box dynamic error. So that is just to be able to use this question mark and propagate or bubble up any of the errors that we find. So we are doing the user arg.parse. This is to read the user argument that are provided on the command line. And then this is the main function, BFS, that is breadth first search or traversal for the website. So we will pass the URL, and then we have to parse it and get all the required links and create an XML file. And once we have those links, we call the write URLs to XML. This will call the XML create and actually write all the URLs to that XML format that I showed in the beginning. Next, the breadth first website. So in this one, simply we take the URL as the argument, and then we are using our custom utility method generate base URL. In the first stage, we may not really need it because user will provide the base URL, but we are using this helper method generate base URL to create the base URL from the links that we find. So as I briefly mentioned in the beginning, that we are not going to parse all the URLs or anchor links that we find on a website. What we are interested is let's see. So this is right here. So we are interested in finding only the URLs that are relative. So they start with a forward slash. So that means this is a relative a URL from the current page or wherever we are on that website. Or if it is start with HTTP, so it's an absolute URL, but we are only interested in the URL that is for this current website or the base URL, and that's where we are leveraging this generate base URL. So whatever HTTP URL we find, it could be an external website, and we will get the base URL from there, and then we are comparing it to the base URL for the website that user entered. If they are the same, then only we will add it. Otherwise, we will skip. There might be some URLs that that have hash, like they are the relative URLs for the current page, but we are not really looking to capture them unless they start with the relative URL or the full URL with the HTTP. Okay, so going back from the top, so this was a base URL. Then we create a URL list. This will be the list that we're going to return from this method that will have the list of all the links that we find. Current depth, that's to keep track of where we are since we are going 2 level deep, so that loop will run twice. Otherwise, it can go up as many levels as user want from the command line. As we say here, like current depth is less than equal to command line depth. Next, these two variables, current parsing, start index and end index, this is used to keep track of the current level. Since we are doing the breadth first traversal, so we are using the single array, so we would know for a specific level what is the starting index and what is the ending index. So that's how we don't go over and just finish parsing all the links for that level before we move on to the next level. So this is what those two variables are keeping the track of that. Okay, so next we are doing the simply URLs to check. So this is, as I was explaining, so we use the start index and end index. So we'll say like, okay, how big of this temporary vector we want to create. If there were 10 elements for a specific level, then we only create 10 elements. Then we go and create a URLs to check, like we are filling it up with the links that for that specific level we need from the URL list. So URL list, in the beginning when we start, we are just pushing with one URL that is a parent. But as we run the loop, this will be getting populated with more URLs. So we are just taking a slice from this one for the current level. So we are if we are on the level 2 and there were 2 links, so this will be an array of size 2, and then just we copy those 2 elements, let's say element 1 and element 2, from our master list URL list, and then we use it to traverse. Here we're starting the loop, so we're gonna go through each link from that filtered or the slice of the master URL list. Then we just printed out that which URL we're gonna be reading as you can see, it is being printed here, loading HTML4. After that, we read the body, like for urec.get. So we are using that one to read the URL and get the string or HTML data from that. And then we are calling our parser to go through that body. So we are passing as a string, go through that body and find all the anchor tags and find the href and return that as a link. Next, we are just checking if the link is not empty. Then quickly the same thing that I just briefly discussed before, that we are interested only on the relative URLs or the HTTP URLs for the current website. We are not interested, we don't want to create a sitemap for the external URL. So we do that and then we validate and add URL. So we'll look at the utility method soon. Then we just add to the current depth, and we are also updating our local variables. What's the next starting index and the ending index from the master URL list. Generate base URL is simple. We are using our URL parser class, so we just provide the full URL, and then we are using two methods from that one: is scheme. That will be either HTTPS or FTP, whatever the scheme is in the HTML URL, and the host string will return the base URL before uh, any other arguments, query strings, or anything in the URL. So that is our generate base URL method. And next is the validate and add URL. So this one is just making sure that we are not parsing the same link again. So if a link was already added to our master URL list, then we don't add it again. So because we may get into a loop where we just keep recursively going back and forth, because it is possible that on level 3 of a sitemap, we are pointing to a URL, or we have a link that is pointing to some page on level 2. So we don't want to keep going back and forth. So that is the purpose of validate and add URL. Last one is this write URL to XML. So we are creating this test XML file. We are setting that indentation should be 4 spaces. So second one is the space, that's the second parameter, and we want 4 spaces. Then there are some important method calls. For instance, we want to output the XML declaration tag. So we have to use this specific event declaration, and then we pass the value that we want to be added, because this will not have a closing tag. So if I go back to the test XML file, so this is the first line that you see on the top. XML version, it is a special XML tag that does not end with the similar tag in the end. So this is the output for that, and then we are starting our URL set. That will be the root element. And after we start that one, we push whatever the values for that attribute of that URL set, for instance, XML namespace, and then we write the event. We can see that right here, and we are not closing the tag. So if we go back to our code, we will be closing this URL set element tag uh, after we have finished putting all the elements right there on line number 131. So we say event end for the URL set. Then we go through the list of all the URLs, the master URL list, and we are creating this URL start tag, and in that one we are creating a lock tag. So just like the URL set, we close the URL tag after we have written the lock, and we are writing all the details for that lock or location element down here. So we have the lock element and the text that we want to print, which will be the actual link, like this one. And yeah, so that's when we finish the XML and we close it. So that was the quick overview of the code. And I will run it one more time just to generate a different XML. So let's do the Gophercises website. So we just run it. This is how it's going to run because Gophercises website on the root URL only have few pages, so it generated 5 of them. Let's go and look at our test.xml file. Now we only see those 5 hyperlinks or anchor tag with href values. So that is it. This was a simple exercise, and as usual, the links for the GitLab for this exercise code will be in the video description, and I will also link to the Gophercises website. I will encourage you to check it out for more details about the algorithm and the requirements, the way they have covered. Thanks for watching, and I will see you in the next one.